Hello, how are you doing?
Hello.
Hey everyone.
Hey everyone, or as we talk in Russia, привет.
Good evening, lads and lasses. How are you doing? How's the weather?
Thank you. It's good. Actually, it's cloudy, but yeah, we can stay with it.
I see. Are you excited about this talk? Did you spend a lot of time making it?
Yeah, actually, I initially was thinking that it will be like pretty quick preparation, but I made like pretty I don't know five or six iterations on improving and adjusting according to different feedbacks. Yeah, and I'm really excited to share this presentation. Hopefully, it will be useful for others.
Have you been on other online conferences before as a speaker?
No, actually, I wasn't a speaker like on public conferences. I have experience speaking within a company, like in different work jobs. I was just speaking internally to the team or to the company, and for the public, this is my first time, and yeah, kind of slightly worried, but yeah,
Congratulations.
thank you.
Yeah, in my opinion, it's good to support online conferences now because we should let organizers leave this period after they can continue offline conferencing, because of they shouldn't stop right now, unfortunately, and we need to support.
Yeah, I agree. Yeah, but it's still a bit more difficult to watch it, online because conferences is not only about talks; it's also about speaking with people. And by the way, that's why this virtual stuff that you can speak and watch at the same time I think, is quite a good idea, in my opinion.
Well, yeah, kind of. I guess there are pros and cons on this online conference. That like one advantage is that many people from different places can just join via online and see and like gather new knowledge and even network there. However, offline conferences were also great. Hopefully, they will be back again. But because you can travel, maybe if it's like in a different city, you just travel and it will be like small vacation and it's kind of another feeling, I guess.
Yeah, it will totally another feeling, exactly. But nowadays, I don't know about why we can continue traveling on the conferences like 1 year, more than 1 year before. Oh, more than
Yeah,
1 year.
Yeah, I even
it's been a
forgot
while.
what was the normal world before pandemic.
But looks like in current year, maybe at the last part of this year, we can see HolyJS offline. Maybe I really
I hope
hope
so.
this.
I hope I can travel abroad soon and to go to conferences as well. Like, I know that there's like the end of lockdown in June in the UK, and I hope to come some conferences like and meetups like React London, for example. But I can't be sure about it.
Yeah, you need to be vaccinated, I think, to travel, and hopefully no one gets like zombie. So yeah.
Yeah, I hope. Well, I'm already, but I'm not too sure if they will allow us to go to conferences and stuff. We'll see.
I heard actually there is a like COVID passport in some countries at least, that you get vaccinated and you get kind of passport for that you are like vaccinated and you are safe, and that's how they just accept like allow you to enter that country. I'm not sure which countries are they, but yeah, I heard about it.
Maybe I hope it will work for us as well. Okay, I want to remain that our viewers, our audience can ask questions, and all questions will be answered. And also don't worry that if you don't know English well, you can ask questions in Russian, and we have special people there who will translate all the questions. And I think we can start, shall we?
Yeah, totally. Yeah, and questions are highly appreciated. So, okay, let's start. The topic of the talk is how we built our custom React SSR engine, server-side rendering engine. And before we start, just short, brief introduction about myself. My name is Erzhan. I work as a principal engineer at TopTal, core team. Previously worked in different places like blockchain startups, Yandex Money, and a couple of other outsourcing companies. Total experience is around 7 years. And yeah, have been working on different stuff like backend, frontend, and even mobile applications. And you can find me on Twitter or on my personal website. So yeah, and this is the short table of contents. We start with a brief introduction. Then there will be background story on like how we started this custom vehicle, or I don't know, custom thing. And there will be summary. And there is a bonus part which is about partial hydration. Hopefully you will also like it. And yep, let's start. So brief intro part is, let me just, for the broader context, who we are. By we, I mean the team that I work at TopTal. Currently, I still work at TopTal, and it's called Growth Engineering Unit. It's not just single team; it's 5 teams actually. And what we do is basically increase number of users coming to our website. We, I don't know, do lots of different optimizations, starting from SEO and Google indexing and so on. Do lots of A/B testing, run experiments to try different stuff, and basically experiment on different new features. And the main thing which is related to this talk is that we built and maintain all publicly accessible pages in toptal.com. So if you go there, any page that you can access without signing in, those pages are basically maintained by this large unit or domain. And background story is, it started I think around 3 and even 4 years ago, that this toptal.com, it was very, very outdated, both visually and code wise. And we had this is how it looked at that time. Obviously some stuff from 90s, I guess. And we had an initiative to redesign the whole website. Since we're working on the public part, we were assigned to a public part of the website. And this was the new design on the right. So we should achieve, this is just a one page example. This is our home page, but there are I don't know, tens of thousands such pages that we need to redesign, redo, and re-implement. And there were problems. Obviously, there are always some problems, obstacles when you do new stuff. And one of them is that we had basically Zua frameworks. Our main backend technology is Ruby on Rails, and it was initially built with only Ruby on Rails, using Slim template and so on. But then there were added some Backbone JS with CoffeeScript, and there were even some experimentation with custom framework on top of Backbone JS, and with mix of Ruby on Rails, and of course jQuery. It's everywhere. So we cannot basically reuse UI, because some pages on one tech stack, another on different, and so on. Basic reusing of small parts is really, really hard in this Zua frameworks. And of course, it causes decreasing development velocity, by which I mean that basically new pages were building even slower and slower, and people were leaving, and also attracting new engineers is really hard. No one wants to work on legacy, right? And the also important part is that newcomers who accept the accept to agree to work on this legacy stuff, they need to spend, I don't know, months to just understand this whole legacy, and learning curve is obviously high. And also page optimization, since our basically job is optimizing all pages for Google and for publicly accessible pages. These optimizations were not cannot be reused because of the different tech stack again. And this is how it looked at that time. Of course, it's very, very simplified. So public pages, let's imagine a new request for homepage comes from user. There is a load balancer, which maps to certain, I don't know, pages. And we had two basically services, like large monolithic. This one, very, very old. These were newer, but still outdated. And both of them contained like some part were implemented here, some part implemented there, and they were like using some backbone, jQuery, and all of the mixed technology. And moreover, these both systems were pretty like complicated in terms of data. They were having lots of logic behind, like synchronization with different internal systems, or manually updated like in CMS, or some automatic synchronization, or some Google pops up, and so on. So we cannot actually like throw them away and start from scratch. So we need to basically live with it. And we had this goal basically, which is a solution that will unify our website look, makes hiring easy, that people will desire to work and will enjoy to work. And this solution should be also fast, SEO aligned, since we rely on organic search. And most importantly, is easy to migrate with existing this infrastructure complicated. Luckily, at that point, we picked React as a front-end standard technology. And we have not only public pages, but also some internal teams, and they also built like single page applications and so on. So we decided that everywhere we will be using React. And with that in mind, like three or four questions were easily answered, like unifies website look, React with some components library, easy to find engineers, of course, React. Fast and SEO aligned, React with some like server-side rendering or static pages. However, the fourth one, easy to migrate, we still didn't have answer, and we started to think about it. And possible solutions that came like to mind is that Gatsby, which is a React static generator, and Next.js, which is a React server-side rendering. Just to note that we are considering these tools at that time when we started this initiative. It was like 3 years ago and even more, I guess. So first we started with Gatsby, and possible integration could look like this. So we have our existing infrastructure, again, load balancer to monolithic services, and there will be Gatsby application, which builds all pages to some CDN, and we can connect to this URL mapping service. And this Gatsby can just retrieve data from these two monolithic services, because data is held on both of them. And they can also trigger some like rebuilds when some data changes, because we need to keep up to date our pages. Yeah, and everything looks good. However, there were problems that there were no incremental builds at that time. By incremental builds, I mean that let's imagine you have like 100,000 pages, and you change some content, I don't know, button on some 5 pages or even 1 page. And you want to obviously rebuild only those pages, because you don't need like rebuilding and like those other pages like 99,000 and so on. And even now, as far as I know, Gatsby incremental builds doesn't work with custom CMS, but as you have seen in the architecture, we have our own solution for the CMS. Yeah, and we have obviously lots of pages, like tens of thousands pages. And sad for us, but we couldn't go with it. And we started another possible approach is Next.js with React server-side rendering. At that time, there were no static static page ability of Next.js, which it has now. And again, possible integration could look like following. We have a Next.js application in parallel with our existing infrastructure, which just serves new pages, and we can gradually move these old pages one by one, re-implementing them, and Next.js can just like retrieve data from these two data sources. Yes, and again, everything looks great. However, another problem is that rendering is still on the fly, which means that when you have basically request coming, Gatsby needs to fetch data from these sources like CMS and other monolithic application, and it takes some time while they like gather, and there is a response also, like network delay and so on. So it was not acceptable in our case. And another like kind of issue is that both of them were kind of limited in customization, and we needed something that we can customize in our needs, because like we have pretty complicated infrastructure and architecture. There were other concerns too, but we will not consider them because of the timing. This is not about them. So yeah, and we jumped to investigating our custom solution. So we had these two things in mind. First, we need React and static pages, something like static, because server-side rendering kind of works, but not as great as we want. And partial builds or incremental builds, which we considered previously that we want to rebuild only affected pages. And we came up with pretty experimental, and I think it's still experimental. I didn't saw any such I don't know, architecture in the community or open source. So what we actually did is that we have everything there again, like old architecture and services, and we decided to build some sort of service behind our backend, which will basically be a very dummy rendering layer or engine, and it doesn't know, it is stateless. It just gets data from post request in the body, and basically renders some page and returns it. And these services just, they can like proxy those pages again back to the user. So yeah, as I said, it's stateless, no dependencies from any other services. It doesn't know about their existence. What it does, it just renders some page by given data using post request and returns HTML. And yeah, like this is how it looks project using that service. We have a like package. It's not open source yet. We are like using it in a private npm registry. It's called Frontier under our domain, Capital Frontier, and it has pretty similar to Gatsby or Next.js comments like start, build, and serve. Start for development mode, build for building your project, and serving to start like this server basically. And the project looks like this. We have main src pages folder, and each folder inside is treated as a page template. And yeah, basically you can create here any component and so on, and the data will be given by like post request. So it expects data in the post request and returns HTML, as I said. And basically you can even use without any service, using just terminal. This is of course example. You will not do this in the, I don't know, in development or in production. I mean that there is just server which runs on Frontier Toptal.net, and there is some URL, and here each page name in src pages, you can just say that render me this page and use this data in a post request. There is of course metadata, like I don't know, some experiments that we run or some SEO related data, and actual data is inside data object. This is just structure that we used. It could be anything, but this was convenient for us. And yeah, it returns some HTML with some headers. About DTAG, we will talk later. It's also important topic that we basically featured that we used for incremental builds, but we'll see it later. And this is how looks the page itself, page template to be specific, that we have this basically data given as a props to component, main component, template component, and we can retrieve, render anything what we would like. I don't know, create custom components and so on. And basically that's it. So everything works. Yeah, as I said, it's not a front end, but rather a backend service for rendering HTML pages. It looks like this. Yeah, I think many people might ask, this is React and server-side rendering engine, but we were starting with the static in mind. And where is it? We decided to solve it in a different approach. What we did actually is that we didn't want to complicate this service. It was very like simple dummy service that we could use for rendering, and about like static or caching will take care of the service which actually uses this rendering engine. And basically they can just retrieve those pages, cache them inside locally, I don't know, in memory or in Redis. We use Redis for now. And yeah, basically cache will be our sort of static pages. Static pages actually is just some pages built in file system. Cache is another alternative that we just have some, I don't know, another source of memory. And yeah, basically that's how it works, and that's why the talk is called server-side rendering engine and not a static page builder. What about the second goal that we started initially about partial builds? Yeah, to clarify, rebuilding, basically when page changes, there are two main, I don't know, parts. That first, that content might change. For instance, title of a button, which is stored in CMS. This is a content change. And second, I don't know, way of changing pages is code change. When you actually, I don't know, update CSS or update a component of a page template. This is a code change. And we'll go one by one. We solve both of them, basically partial building, content change first. It's very easy. How it works is that initially when this our service starts, CMS, it also has built-in router. It goes through all pages that it has data for and renders all of them and caches them somewhere in Redis or in memory, and then it just serves from the cache. So first time it goes to all pages, renders them, and after that all requests are just served from this cache. Whenever CMS updates some data, like title of a button or navigation, logos, whatever, that page, since we know in CMS which page content changed, we just go and say like, hey, give me, render me this page. And then we just regenerate or invalidate here that cache, and there will be new version of that page. That's how we solve the content part. Yeah, and we basically skip rebuilding the whole website. We know exactly where data changed, some button on some page, even it might be shared, but like shared data, like let's say some navbar that is used in 5 pages. We know that these 5 pages only affected, and we go and just update them. It's very instant. And regarding code change, so basically when we in our source code in React update some CSS or JavaScript, whatever, there is yeah, and of course when we redeploy our service, also we need to, I don't know, detect what actually changed. We don't want to on each redeploy to go through all like tens of thousand pages and rebuild them all, because it takes, I don't know, half an hour or even hour. We wanted very instant updates. How we solved is that, yeah, and this is the issue, that since we like redeploy new version of this service, this CMS doesn't know actually. It used a previous version like of home page template, of like article or blog post template and so on. And we didn't want to like again to go through and rebuild all of them. And we started to thinking, is it possible to detect actually code changes in our project? So yes, and it's possible. This is kind of I don't know, HTTP header standard, I guess it's called ETAG. It's a site from MDN Mozilla, but in short, it's just versioning of a particular resource. It might be CSS, it might be any basically asset, it might be some images and so on. In our case, these are page templates or HTML basically, and how we can detect what page change it, what page template change it, is that we used Webpack stats. Under the hood, building is done by Webpack and with like pretty sophisticated plugins. Specifically, we use Webpack stats plugin. It's just a simple wrapper around Webpack stats. It just transforms in a nice way that we can use. But yeah, it doesn't add any I don't know new stuff. It just retransforms. Yeah, again, this is our project structure. We have pages, and each page template here about blog post. This might be singular, and or like I don't know, there might be multiple versions of about pages. It doesn't know. It just gets data and updates. And this how looks. Of course, simplified Webpack config that we just use the stats Webpack plugin, and we can say that like output statistics of what you had during the build to a certain file like stats.json or anything you would like. And there are some configurations you can fine tune and find some right output for you. And yeah, we just trigger frontier builds, which builds all our client project and also outputs this stats.json. And it has this structure basically for each entry point, and entry points we configured so that each page template in these SRC pages is treated as an entry point to Webpack. And thus we have like different chunking and bundles, and we have a like kind of statistics for each entry point, that what assets it depends and it needs to when rendering the page. And this assets folder might be like any different. You can configure, we configure it in this way that we have like 5 or up to 7 assets. You can chunk even more, it depends on your needs. And yeah, there are some CSS, JavaScript, whatever you need. So we have kind of graph of entry points, and these assets basically change if some link to a certain entry point asset changes. It might be it like I don't know, CSS or React or JavaScript. So here, for example, we have these entry points, each page template, and they use inside some components, let's say about hero and so on. And whenever some component, let's say this component changes, we have different asset for all the depending entry points. So about page, home page, and contact, all of them change. But for instance, if we have this only home hero change it, then these assets, basically stats file and assets array doesn't change, but only this home page gets a new basically array. And given that, we can calculate exactly did some page template change it using just hashing of these arrays. You can use any other logic. We used very simple one. We just take these all strings, concatenate it, and use some crypto library and just make like this standard hash in a hex way. So, and we use it for versioning that page. And how it works is that first time when we run all our services, it as I said, it goes and renders all pages, and it stores not only HTML, but also stores that header inside that was responded by the service, and that ETAG will be kind of version for that page. And next time we just even don't need to like do a post request. We use head request because it's very simple and there is no data you need to send. And we just go and say like, hey, this is the home page and this is the ETAG that I have previously, after it deploys, of course. And it just checks with the new ETAG and responds like 3 or 4, no 304 not changed, I think, and 204 is no content. So if there is a 304, then we just skip that page rebuilding, and if it's 204, then we just regenerate that page again. So yeah, this is kind of it, and it also works even after redeploys of this service. It takes, I don't know, if we only change it some minor stuff in a single page, it just takes like, I don't know, minute to rebuild only that part, and all our tens of thousand pages are remain the same in the cache. And yeah, kind of works well and looks good. And maybe you are thinking, is it the like, is it all? Uh, Kinda, if you see this architecture, it's pretty complicated. And imagine you have working on a new page locally. You need to run these all services, this old monolithic CMS, and this and so on. And it's, as I said, simplified. In reality, we have lots of other dependencies. This monolithic service has its own, I don't know, other services like Redis, Postgres, like Google PubSub, and so on. And even if you use Docker for local development, your machine will burn basically, because there are dumps of like database dump of 50 gigabytes or so. So it will be like very, very hard for developers to enjoy working. And it was sad for us. We didn't want to do and like complicate developers' life. So we came with a simplified approach on the development mode, which is just since data is since data comes from the post request for development mode, we decided to mock the data inside some JSON file or JavaScript file, and locally we can live with that just a JSON file, and it will be used as a kind of page source. And only on the production mode we need to run and check for post request and so on. So yeah, and how it looks is that each page template has its certain meta folder inside which we have this mock JSON, or it might be JavaScript if you need to dynamically build this mock file. And yes, it kind of works, and it's much faster and easier for development mode. And how it looks, this JSON or mock JSON file. So we have again the same meta structure. This is again, as I said, this is the structure that we used. You can use any different structure. Of course, you cannot use it's not open sourced, but yeah. And data is actually the page data. There might be title, there might be some other sections, arrays, and so on. This is just a like pure JSON file. And yeah, you just take it. In development mode, this data comes from mock.json. In production mode, it comes from the post request body. So that's how it works. We use this frontier start, and it works with all the hot module replacement and reloads and so on. Yeah, and locally we have basically, instead of render here in production, we have def page, and it listens on a get request. If in production we use post request, in development we use get request, because data is stored inside this source code. Yeah, and these are some examples. For instance, if you need like about and contact and so on, just like go to this URL and check it. And yeah, this is how it looks. This is production architecture when we deploy to production or staging. And this is locally. You don't even need anything to run. It's just a frontier start and you are done. You can just develop and that's it. It's simplified way, I don't know, further than it was previously. This is components of this, our tool. We have CLI, obviously. We have production server, which runs on a post request. We have development server with hot module replacement, and everything is built on top of sophisticated Webpack configs. And there is a public API, which is, we'll see in the bonus part. It's just some utility functions that this tool exposes. And yeah, this is how it works. Again, you only have this structure of project, these dependencies and scripts, and it works. Let's talk about some pros and cons. Of course, there are some cons too, but let's start with pros. It's stateless, as I said. So it's very, very easy to run locally and test, and it simplified developer experience way much. And there is React, and we share all the components between different implementations. We have chunk bundles we can configure depending on our needs, and each page has its own chunks, not like one chunk for all pages, which will be not optimized. And relatively easy, kind of relatively I put, because you need to do some part on your service. If you have some, I don't know, old monolithic service, and you need to do some integration part, but it's much easier rather than starting this monolithic from scratch and rebuilding whole logic for data synchronization. Regarding cons, as I said, it's not the out of box solution. It's only for those cases when you have to live with your existing infrastructure and integrate with it. Content needs to be provided, and there is no routing. I mean, real routing, because it just renders and returns HTML. There should be some router. In our case, it's these monolithic services. Future roadmap that we think is we even recently thought about maybe we can switch to Gatsby or Next.js. After trying, we figured out that our solution is still works best for us, and there is no need to go and redo everything. And we maintain and we continue to develop. Currently, it's kind of bound to our infrastructure, but we want to clean up and make it reusable for any case, and maybe at that time potentially open source if we agree with the management. So hopefully it will be also released and we can announce it. Yeah, and summary is that, I mean, the main point of this part of the talk is don't be afraid to experiment. When we started, actually I joined at the time when this decision was already made by other engineers, and I was thinking initially why we need to do our custom vehicle, or why we can't use some stuff. But we really enjoyed building this thing, and it works perfectly for us, and I don't regret about it. I mean, at least for these 4 years, even that we had this old monolithic application, we were enjoying development experience. We were using the new technology stack for the front end part, and we were not binded to our other services. But of course, there are some nuances that you need to take responsibility. Currently, we still maintain and continue to develop because it's our tool for all the publicly accessible pages. Yes, and kind of this is it. Next part is the bonus part. We can continue, I guess, if there are no questions on the first part. Just let me check the chat. Okay, I think there are no questions. Or yeah, we can go with the bonus part. Bonus part is about partial hydration, which is related to the issues that we had during, not during, but after we built this solution. Let's start with what is React hydration. I think many of you already know, but just that so that we're on the same page, let's start with the very first part: is what is hydration and why we need it at all. So hydration is, this is again cited from the official React documentation, but again, in a simple words, you need hydration in order to make, of course, hydration is only in server-side rendering engines, and you need hydration in order to make all your components alive in browser. By alive, I mean that, for instance, if you have event listeners on your button, it doesn't work if you don't hydrate. Basically, what happens on server-side rendering, you just have dummy HTML, that's it. In order to make it alive, like JavaScript working and React DOM working on the client, you need to rehydrate that. And how it works in a very abstract way, that on the server part, we use this React DOM server and render our application or page using this React string. It just creates our the whole DOM in real HTML, which we can send to the client. But what is interesting is that it also sends a copy of props of the whole tree of your application. And on the client part, React DOM Hydrate takes this copy of props and basically re-renders the whole virtual DOM, maybe not the actual DOM, but at least virtual DOM. And at that time, all the event listeners are attached to the components, and you kind of have a real kind of dynamic page on the client side. Without Hydrate, you'll have just a static HTML. Yeah, and regarding the sending props, it differs on the implementation of server-side rendering. It might be some sent in data attributes, like data attribute, and they just send stringified props, or they attach to the page like using just script type application JSON, or they fetch it in the client side, or they use just, I don't know, window data or any variable to store it and use it on the client side. So, but what is interesting and what is the main point is that we have to twice overhead. So we already have that HTML and all data rendered, but we also send the copy of props at least, which is kind of not cool. And as I said, since we are doing these public pages and performance is very very important for us, we started to think how we can solve this problem. But yeah, first let's take an example. Let's take a look on an example. This is my personal website, which is built in Gatsby. This is static page, but I just wanted to share how basically rehydration in this double twice overhead works, so that I have this page rendered and statically built. But if we just check the source code, there should be some JSON. Basically, this thing is fetched again on the client side. All the data that we already have here, which is rendered in the HTML, we need to fetch again and reapply and re-render the whole tree in order to make it dynamic. If there are some stuff, I don't know, if you have buttons or any other dynamic logic that uses states and so on of the React. And yes, so kind of not cool again. In public pages, what we do is most of the parts are static. They are really static because these are landing pages, and we have only certain parts which are maybe widgets, chat widget, or some search widget, or some button, and so on. They which have their logic like in React using some hooks and so on. And we decided to think can we avoid actually for all those static parts of the page to be rehydrated, thus save this overhead of sending copy of props. And yeah, we found this approach, which is called partial hydration. How it works, again, in an abstract way, that we have pretty much the same on the server side. Of course, you need to adjust logic, but what is interesting is that we basically split our one page into multiple small React applications. So each this component is treated as a small React application, and we can mark only those which are dynamic, which needs to be hydrated, and they will have their own copy of props. And for the static parts, we can just render them and not even bother about how they are treated in the client side, because they are just static ones. And on the client side, we go through all these small pieces of React applications and rehydrate them each one by one. Usually, on one page, there might be two only component, which is dynamic, and it saves lots of I don't know data and kind of boosts page. How it works in our case, as I said, this Frontier has public API, which is some utility functions that we built inside. We just wrap all the components that we need to be rehydrated into this function that makes some logic to apply and render props nearby the component. And by default, we don't hydrate the whole application. So in this example, we only hydrate this navbar and cookie banner, and they are just used in namespace component inside Hydrated, and all the other parts like layout and footer and so on, they are just static HTMLs. Yeah, and in our implementation, we even went further. So we need this dynamic logic usually when like component is active on the screen, and we decided what if defer that rendering hydration of the component, because hydration also takes some time. I mean, JavaScript needs to be parsed and you need to run it and so on. So we decided to try the approach of deferring it, and it works. I can again share. This is homepage of TopTal, which is built using this custom rendering engine. And if we go to the DevTools, basically, yeah, we see this is of course already built components, but yeah, as you can see, usually in single page application there is one root component, but we have multiple of them, already 4, but there are more of them. So if we start scrolling a bit, there appears one more, another one which just rehydrated, and we see in these DevTools, React DevTools, and so on and so on. So basically, this rehydrating of not visible part is deferred until we scroll and we're close to the visible viewport of the user. And it also boosts, like gave some boost on the performance part. Yes, and let's go to the slides. Again, there are always pros and cons. You need to live with some trade-offs if you choose this feature, or I don't know, this approach. Let's start with pros. Is that you obviously we were searching for just saving some data, and it solves it. Instead of like twice overhead, maybe some 1 and 2, there's still copy of props sent for the small pieces of components, but at least not the large whole page itself. And of course, JS bundle is also less, and also on the runtime, you don't need to run all the JavaScript in the beginning, and it can be deferred, and it can be less. And on the downside is that since each application is a separate, each component is a separate application, React cannot share context. So if you need some context between like one component, which is its own application, and another component, there is no way in our solution, but we don't have context usage at all, because we built mostly individual widgets and static pages. And of course, as you have seen in the example, that hydrating is done manually, so you need to like basically bear in mind like what component needs to be hydrated and what is a static one. So yeah, these are some downsides. Just I have to highlight because these all the people who are working and who worked in the past or are still working on this custom solution, and yeah, these all the contributors. These are some resources that I used in the presentation, and yeah, kind of that's it. This is the end of the presentation. Thank you for your attention. Do you have any questions, Alexander? Is there any questions?
Yeah, exactly. Let's make me breathe out of this talk. So first of question, it's about your realization. Is the solution used only for legacy components or for new components too? That is not going from CMS.
For new components too. So basically, the front-end part is just a pure React. So we even reuse some components with other internal teams who are building actually single-page applications. They don't use our rendering engine, but we reuse React components. This way, we on the front-end part, we are on the same level and on the same standard. So this was the main point of this custom solution, that we standardized the front-end part.
Whole front-end part standardized with the solution. Yes. Yep. Sure. Looks like just for me, as far as I understand, is a better solution to migrate from a whole WordPress like stack to front end on React, as you mentioned in the first part of the talk. But what about not only on TopTal core team? Is it real to just wait for this library will be go to open source, or is better to make your own solution and don't wait for your library?
This is a good question. Actually, I am really voting for open sourcing it and starting this initiative. However, as I said, there are some friction not only on the agreement part, but basically before open sourcing, there is one blocker thing is that the code base is still bound to our own cases. So it's kind of, there are some hard coded places where it works with our CMS and our infrastructure, and we're currently working on unbinding them and making it as a separate tool like Gatsby or Next.js, which you can plug into your own I don't know, CMS or some other solutions. And there is another part which is open sourcing. TopTal like previously worked on the Ruby on Rails stack, and there are lots of Ruby on Rails open source libraries. So basically, I think like real rock stars working in TopTal, I mean on the Ruby on Rails part, like Ruby rock stars, they have like lots of packages with thousands of stars. On the front end part, however, we are just warming up. We already have a few open source libraries, but this one I think will not be soon because we anyway have this whole work, which is kind of not our main work. This is done as a tech debt at like 20-30% of our time when we work on a real like business product tasks. So I think this will not go to open source in near future, maybe at least a year, but who knows? Yeah, maybe at some point we'll make it open source.
For other hand, maybe it's better to make your own solution and don't wait for you, because you already provide this info.
Yeah. I didn't provide it with the real code implementations for sake of timing first, and also for the NDA purposes, since it will be basically kind of sharing the code base of the company. Initially, I was thinking, and that's why I kind of provided high level like overview of the architecture and some main points how it can be done. But yeah, I think like with this knowledge, you can build your own solution, like using Webpack configuration and all the logic behind it. So yeah.
As I understand, your custom solution is better to don't refresh all of your static pages bases. And, yes. But how many time you really save with it? Build time exactly.
Yeah, we have actually lots of content editors. We use CMS very often. There are some people always changing. There's someone always changing some stuff on our page using our CMS. And that's why actually we didn't take Gatsby, because if you need some page to be updated and be live after 1 or 2 hours, even after you change, then Gatsby might be okay. But since we were very this was number one requirement, we start with this one, and we saved it a lot. So basically any update on a single like page, it's done instantly. So it takes maybe a few seconds because we specifically know which page changed it, and we go and just invalidate cache using our renderer, and it works.
Yeah, looks good. But in case of Frontier will update it, you should refresh all of your pages, right?
No, in case of core part of the Frontier, you mean?
Yeah.
Or
sure.
the no. Actually, this like basically ETA calculation and this graph calculation was implemented this, I don't know, like 4 years ago in the beginning, and this part doesn't change it. So this is the main thing that calculates if the source code changed. So even after like new package of Frontier, if this ETA calculation didn't change it, so pages can be used like old cached pages. So the main thing is this function that I shared, which calculates the ETA.
Yeah, sure, got it. Looks like that your frontier library is just a server-side library that accessible via HTTP requests, and looks like it's a good candidate for another CAAS solution, the solution that goes
Yeah,
as a
exactly.
service on your site only. Just let them go to a repository site to go to code from repository on GitHub or GitLab or and so on, and let them server site on your servers.
Yeah,
What
actually, this is a great idea. I didn't thought about it like as a service. Yeah, what I was thinking is that since this is only part of a solution, as you said, this is a service and not the whole solution. You need this routing and this service behind, like before this frontier. I was thinking, like in the past, I was thinking maybe to add the CMS ability, so it has, you can just plug, I don't know, inside frontier.config, we have a certain config folder like getB config, and inside you can provide some I don't know, credentials to the database, and we can just provide you out of box CMS ability, but it seems too too ambitious, and we don't have that much time for now, at least, to spend on making it like CMS integrated into the frontier out of box. So we'll leave with this part of the solution.
Yeah, looks like many big companies have their own legacy solutions, not only on WordPress based, and looks like maybe it's really hard to integrate solution like yours without any contract file, like a big config file in the repository that really stores all logic about caching or tree shaking of pages.
Yeah, exactly. Yeah, these two, as I said in the beginning, these two services, they are one is kind of outdated monolithic, which we are splitting, and another one CMS. It was created maybe like also 5 years ago, and it is kind of updating, and we are very like okay with that solution because our like managers like the solution. We have our own CMS UI, which works nicely, and it shows you when you change data, it just shows the preview of the page, how it will look, and so on. So I don't think that we can or we want to go to another CMS because our CMS works perfectly for our needs. So yeah, for business, it's the number one requirement, I guess.
Yeah, understand this. Any legacy solutions work perfectly for their needs, exactly. And
This
mhm.
Yeah, this CMS actually it kind of was a legacy, but it's built on Ruby on Rails. Actually, I'm not sure if I can share, but I think there is nothing wrong with it. So it was built in Ruby on Rails, and it was legacy on the pages part. The actual CMS itself, it is updating and maintained and like even developed currently, and people were thinking even making it as a service, like as you said, as like SaaS service, CMS as a service, like I don't know, Contentful or any other services, because it was so nice and people were like our content editors liked it much better than the existing solutions. But again, I'm not sure on that part too, because it's a whole different story. Like Ruby on Rails guys can tell a bit more, I guess, in the topsoil part.
Sure. Yeah, we use Contentful in our small front-end society in St. Petersburg for our site. It works as perfect as our CMS. CMS like a CAS service.
Yeah. I used Contentful too, yeah.
Yeah, and we just using GitHub pipelines to save our money for server. Looks like we absolutely have no server. We just have static generator based on Gatsby.js that works on pipelines in GitHub.
Yeah, looks good. And does this Contentful have ability to basically like add some logic synchronization, data synchronization logic, or it's only UI manual based change?
Oh, it's just UI manual based change. It's only one webhook to start whole pipeline for all pages. It's not like your clever solution.
I see. Yeah, got it. But yeah, I guess for simple cases, it's perfect. But yeah, for more enterprise like needs, it will be like too limited.
Yeah, looks like your solution is better for legacy projects when developers really knows what they need. Because for starting off migrating on a React stack on the front end, maybe it's better to just go to Gatsby.js, connect GraphQL connectors to database of, for example, WordPress database or another CMS database, and just grab data using GraphQL to Gatsby.js and generate all pages for one run.
Yeah, kinda, but I think I think most of the times Gatsby will work perfectly. And as I've shared, I use it even for my own needs, like for my personal website, and I like it a lot. Uh, but there are maybe some cases when Gatsby will be not the right solution. Like for instance, imagine you have a e-commerce site when you need when you need data change it like immediately when you need update price. If you have, of course, server-side rendering. If you do all the fetching of like prices on the client side, then it's another story. But if you do all server-side rendering and you update it price, and you get the updated page with the new price after 2 hours, it will be like, I guess, not acceptable for e-commerce side. And for those needs, you need to find another solution, like maybe Next.js, or like building your own tool, or you just like reject the server-side rendering and accept the like just rendering like, I don't know, important parts on the client, like fetching. But it will be again bad for the SEO for like SEO part, because Google, if you have more data, Google will know and give relevant answers for like for the searches, user searches. So server-side rendering for e-commerce, I think the important I don't know, part.
Mm-hmm. Oh, I know about good question about SEO. For me, SEO looks like a magic, but magic that can really save the money. And what about really savings of money that you have?
Yeah, well, we actually, I will not share, I guess, the exact numbers, but since starting this like initiative, because previously all our users were coming from paid media when you like have these Google AdWords and so on. But gradually, because it's kind of works, but it was expensive, right? So for each user, you pay some like crazy amount of money for each click, which might be user is not even converted to a real client. So it just comes with you using, I don't know, ad, and it just doesn't go like further. And we started basically investigating on this organic search part and increase like gradually. So we're still increasing. We have paid media part, but it's way less than it was before. Like maybe before it was, I don't know, 90% is paid media, 90% of our users, but now it's way less, maybe reverse. Like we have only few paid medias, and most of the part is from the organic search. And you have free users who come using just like search engines, Google or other search engines. So yeah.
Looks like people prefer more organic search, except advertisement, advertisements. Yeah,
Advertisements. Yeah.
advertisements. Wow.
No worries.
A really hard word for developers that not do this.
I think so. Yeah, even myself, when searching something, if I see like 5 ads on top, I kind of go through them, but I like also check the other ones, which are just like real results from the search engine. So because they might be also valuable. So yeah, I think ads are treated as something suspicious. You kind of have ads, but it might be something that just company wants to sell you and you didn't find it yourself, but someone is providing you like in the face, here is it.
Guys who are watching us or listen us, it's a really good point to sell to your corporation idea of let's make all static rendering based on React site, because of this can save your money. Well, it's a really long road exactly, but I think it works better in case of you start talking about it with your teammates, your company, director of your company, and so on.
Yeah, exactly. I think this basically SEO and organic search is a whole new, I don't know, like new thing that you need to investigate. There is one part, very important part, is the page performance, like how it performs, how well it renders, and depending on that, you get the ranking on the Google search. So, and another part is actually the content part. Actually, you need to put relevant keywords, relevant data, and you need like have perfectly accessible pages. Like every image should have alt text, which is kind of another, I think, art. Maybe alt text is not the something that you just put some text, but something in the context of that image and so on. So yeah, this is a whole new I guess topic which can be another talk.
And let's talk about your bonus part. So the most magical thing about partial hydration. My first question, it was about accessibility, partial hydration and accessibility. So what is actually will happen in case of I just go to the first frame of the page, just load it, and start print it, just print it using printer. What happens in it with another components that I really didn't see right now?
Yeah, basically, when you go to any page, in our case, you have the whole page already rendered. So already rendered, but without no JavaScript logic. But you still have the UI part. So you can actually render it, you can actually print it, write it how it looks. Of course, if you have some components which, I don't know, manipulate some stuff on the client side to render, but yeah, but anyway, we have a server-side rendering, so I think it doesn't anyhow affect printing, because printing is about just look. There is no click events on the print, or click events should fall back to, if you have link with on click, you need to fall back to just pure like hrefs, so that on the print you will have the links correctly working.
Oh, looks good. And looks like that keyboards events that goes from one tab index target to another tab index target. It will work perfectly. Yeah, because I was wondering about that you show us developer tools, and we see the components that really starts adding to the end of the list of components while you're scrolling the page.
Yeah. That actually, just to clarify, that adding is a React DevTools, right? In the HTML part, we have already everything rendered, all page. React DevTools only sees React itself, like virtual DOM. So what is actually added to the list is that this part of HTML became alive, like using this attached event listeners and so on. So yeah, and tab index is just tab keyword accessibility is just about like pure HTML. You just put right tab index and so on. So it just works even without hydration. So it shouldn't be an issue.
And you told about the first part of your talk. You told about that React solution is better to start hiring only for React developers. And is it really works?
Sorry, can you repeat the question?
I thought about you told that React solution is better to hire React developers. You have more developers to hire on the free market. And is it really true to just make your stack all of React, and it's better for your hiring or not?
Yeah, it's perfectly, I guess, like makes sense, and it works better because the whole front-end engineering is on one stack, and hiring, of course, I mean, everyone knows that there are lots of React engineers, and compared to maybe, I don't know, Ruby on Rails front-end engineers, right? So, or backbone, like knowing, and even if someone knows it, never tells that he knows backbone, because like obviously no one does want to work on legacy. And yeah, hiring made much more easier. Interview process is also consistent at all teams, because initially, like when we had different tech stack, we need to hire depending on the team needs, because one team need like working on backbone, one team working on pure Ruby, and depending on the different interview paths. But now we have all like standardized. And also within a company, we can shuffle people, and it works perfectly. If someone bored to work on one team building some stuff, he can just like switch to another team, and it's the same like tech stack. Of course, there will be another application, like another libraries used maybe, and so on. But it's again JavaScript, React, and it's the same.
Yeah, interesting question that goes with it. It's all about how to deal with existing developers that already maintain application. Do you have many developers in your team that works in runtime with the application, and you make your own solution that refactor all of your site, all of your application, and looks like you need to deploy it module by module, or you need to freeze all of your development and just refresh all code, and after that every developer will continue their production code.
No. Actually, we don't have such problem. I mean, I don't know even how it can be blocked, because we kind of develop in a single repo, like kind of mono repo in public pages. But there is we have our CI pipeline, so nothing broken will be merged to master, unless you are making like drastic refactoring of the whole stuff. Basically everything works. People just from different teams do their own stuff. Of course, we sync on some components. For instance, some team making like some component for certain page we want to reuse, we just don't do it like twice. We just maybe think, hey guys, like maybe you do it, and after we can reuse, or like we can pair and do it together to make it faster. But yeah, there is no blocking. Everything like with pull request reviews done, and basically we have everything deployed without blocking. So yeah.
Well, on my company, we just like to make code mods for this solution, because code mods working faster than my hands exactly, and it looks the better solution to make automating things.
Yeah, we used code mods for some stuff, but yeah, not for the daily basis, I guess.
I'm really sorry for interrupting you, but like we don't have much time yet, and you can continue in discussion zone. If our audience have any questions, you can ask it there. And for now, I'm just saying thanks for your talk, and see you later. Goodbye.
Thank you. Bye
everyone.
Bye,
guys. See you in Zoom room.
Yeah, feel free to join. Bye.